Hi there, I've just updated Decal Champ to version 1.2, so I thought I'd record a video to go through some of the changes because I've made quite a number of changes to the functions, the file structure, and added some new features like Triplanar and Parallax Occlusion Mapping as sort of some more advanced options. Just when you open, you download Decal Champ, it does come with a project. You open the project, it will look exactly like this when you start. And then, of course, if you want to migrate it into your own project, you just right-click and migrate the Decal Champ folder over. It also comes with a new demo scene. Really what I've done here is I've just laid out the profiles. I'm not going through how to use Decal Champ in this video because I've got other videos for that. So please check those out first. This is really just going to go through what's changed in this latest version. Okay, so one of the things with the standard decals I've added is a new option to control the emissive or the glow essentially of a decal. This is really straightforward. It's basically when the primary texture, you can see over here I've got an emissive, and the same with a secondary texture if you want to use it. So if you make them 0, it essentially will not, it will switch the emissive off, which is going to be the default. But when you want to do any kind of sort of glow effect, as you can see here, then you can play with the emissive to adjust those values. So you can see here what that can do. Okay, one other thing I just added here was just as an example really is the Decal Champ is not really designed for you to use the existing profiles. They're really just sort of showing you how they're built and places to start. You probably should use Megascan textures. They're a lot better than the ones I've included. And this is just an example again of using Decal Champ to create a custom decal. And in this case, I wanted to create rust. So this will be in the demo scene, but it's not a profile that's saved. And again, the idea is you don't just use those profiles. You can really create your own and do anything you like. Okay, so that's really it for the standard decals. So just the emissive variable, which has been added. I have made considerable improvements to optimize Decal Champ, so please check that out in the README file. I'm not going to go through all of those in the video, but there's a bunch of things here just make it a little better on the memory, etc. So on that note, let's jump over to Triplanar. Okay, if you're not familiar with Triplanar, Triplanar is a way of projecting a material on all 3 axes. So by default, standard decals will just project on the axis is facing, and it will either stretch a perpendicular axis, or in the case of Decal Champ, you can actually, there's an option just to completely remove it. So with Triplanar, what we're doing is actually, it's a bit more expensive, but we're actually going to project on all 3. So when you've got decals that you want to overlap surfaces, just like these are set up here, again, they're in different angles, we can do that successfully here. A couple of things to mention with Triplanar. Actually, both Triplanar and Parallax Occlusion Mapping, they use different blueprints, so they can be found in the Advanced folder. You can see there's one for Parallax Occlusion Mapping, one for Triplanar, and then you'll see the blueprint right here. You could just drag that into your scene. Something else to mention with these, actually again, both Triplanar and Parallax Occlusion Mapping, is they don't have profiles that you can load. The reason I did this is because the profiles themselves, just like they come with the standard decals in Decal Champ, they become a dependency, and you'd have to do a lot of work to clean them out. So I really didn't want to add more dependencies, particularly as I don't think a lot of people would use much Triplanar or Parallax Occlusion Mapping because they're very expensive. That's why I originally never added them to version 1 or 1.1. I decided in the end to add them because they are both they're both very powerful, and I mean they could be used sparingly and you could get away with it. So now I have also used a fairly cheap version of Triplanar, about the cheapest I could find. So again, if you've used Triplanar before, you may have sampled your texture 3 times, which is usually what happens. Oh, there we go. So you sample each texture 3 times on each axis, essentially. So I've used a different method. You can find it in the material functions, but it essentially manipulates the UVs, so each texture only gets sampled once. This is huge, a huge performance save, but there are still extra instructions. Right, so I've made it as cheap as possible. There's a downside, by the way, to this method, which I will show you in a minute. But again, I've tried to make it as performant as possible, which I always try to do with Decal Champ. Okay, if we have a look at one of these examples here, I'm just going to quickly show you how it works. So there's no profile. Instead, what you're going to do is you're going to drag it into your scene. You're going to select a format texture. A mask format. The mask format there's not as many as a standard Decal Champ, but basically your basic masks are just saying, look, I'll supply a mask. That would be the mask, and then the tiler allows me to sort of manipulate the size and scale of it. Linear fade is things again where you want to fade it out, so things like this down the wall. That would be where you might use a linear fade mask. And then other options here, all the procedural, again, if you've used Decal Champ before, if not, check out the other videos to understand how the sort of base version works, but the procedure mask gives you a lot of flexibility over the mask itself. I use a procedural quite a lot because I like the variations I can create with it. So with Triplanar here, so you can see I've got a blood example. See it's fairly sort of thick blood I've created here, and that's just by creating a sort of fairly good normal strength on my mask. The ways to really manipulate it are the movement of the movement of the decal itself. So you can sort of try and find the position you're looking on the movement. But the main areas you're actually going to want to play with are the mask tiler. So the mask tiler, you'll see, this is where you're going to sort of be moving things around to try and make it look good and make it fit. And then, of course, the various tiling options if you're using the procedural mask as well. And you can sort of mess around to kind of find a look that sort of fits your need. Okay, a couple of other things to know about Triplanar. So I'm going to jump over this section. Okay, so first of all, I've done a comparison. So this uses the standard decals, the standard Decal Champ decals, and I've just projected each one. So I'm using 3 of them. They're all projected onto the respective surface, and they all work fine. So that's no problem. In the case of Triplanar, this might look like a good place to put a Triplanar decal because we want it projected on multiple surfaces over a large area here. It works, but there is one major drawback, and that's the normals. It's hard to tell here. I've actually softened the normals a little, but I've specifically picked a fairly sort of deep normal example here for this to sort of showcase what I mean. But if you look carefully, these are actually the wrong way. The light is coming right to left, but these are set up as if the light is coming left to right. So I think this is a problem just with the way decals work, because they work in sort of tangent space. I've looked online, I could not find a solution. I've seen marketplace tools that that sort of do decals, in Triplanar. They've got the same issue. So if I can ever find a fix, I'll update Decal Champ. But right now, I think it might be an engine limitation. So just bear in mind, again, it's not super obvious. And again, when you're not using high normals or any normals, then you wouldn't notice it, right? These are very soft, things like blood, things like that. You're just not going to see it, so it's not going to be a problem for you. But just know that anything where you've got deep normals, they are going to come out incorrectly on the perpendicular surfaces, and that's very unfortunate. The last thing I wanted to show on Triplanar was and I'm going to show that over here, is by default it does world projection. So there is a new option I've put in the mask tiler for the Triplanar decals that says allow scale. In the standard decal and the Decal Champ blueprints, you'll know there's a scalability option, and you can choose if you want to scale something across a space like this, so it's not square. If you don't do that, it will stretch it. In the case of the Triplanar, because it's using because it's using world projection, it doesn't stretch it. What it does is it just sort of reprints it over that space. So when you're trying to drag a decal out like this, you're going to want to allow scale, and that's going to allow you the flexibility to actually scale decal properly. Now, funny, and by the way, when you don't need to do that, you should generally keep allow scale off. If you have it selected, you'll sometimes see things like this where you get these streak marks. You can mess around with the tiling and that to remove them, but it's a lot easier when you take it off. It works a lot better. Now, funny enough, when I put this in here, this is the standard decal. Again, it's a big square decal. It looks like concrete spilt over, or cement, sorry, spilt over some steps. You can see I'm not putting the scale on, don't need it. But one of the sort of side effects I quite liked is this is the same, but I actually put the allow scale on, and it gives these sort of streak marks at the edges. So I quite liked it. I thought it was kind of a cool effect because it sort of looks like the concrete is sort of dripped down a bit, you know, with gravity. So again, I put that as an example. You can play around with that, obviously, and experiment. So there is one major drawback to Triplanar and using it this way, because like I said earlier, it's a fairly cheap way of doing it, but you'll see it here. This method actually does give you these seams in some situations, which obviously don't look very good or very realistic. Now, again, it will depend on the use case. You can see most of these examples I've got, you don't really get those seams. They're not, you know, they're not very obvious, and you don't really see them, but you'll see them in certain situations like this. You know, there may be ways to blend it. I couldn't find ways that really worked, again, with decals in particular. This may be something I look to update in the future to try and sort of smooth that out. Most of the time, like I said, I'm not really seeing it, but that's just something I wanted to call out. It is something to look for, and again, it's really the price we're paying for trying to make Triplanar as cheap as possible. Okay, so if we jump over to Parallax Occlusion Mapping. Okay, for those of you that are not familiar with Parallax Occlusion Mapping, this is a way of essentially faking the illusion of geometry, real geometry. So you can see here, these are all, again, they're just material projections, but they give this illusion that these are all 3D, and this is real geometry. You can see they look pretty nice. Now, Parallax Occlusion Mapping, by default, struggles with the standard decals in Unreal. They don't rotate well. You get a lot of warping, particularly when on different angles. So again, this has all been solved with Decal Champ. So they work on any angle, but you'll see if you ever try to create them yourself in a standard decal, you have a lot of problems with them. So hopefully I've fixed all of those things. They are quite expensive. There is an optimization built in, I'll walk through, and you can obviously, you know, optimize them in different ways yourself, whether you use shadows, etc. But just know that, again, I wouldn't be using a lot of these in your scene. Maybe use them for very sort of special or particular, you know, items. Okay, so if we just have a quick look, we'll take an example here. The mask format, just like the Triplanar, again, you can find them in the advanced folder, POM. You'll find your decal here, you drag it into the scene, but just like the Triplanar, there are no profiles pre-built, because again, didn't want to add additional dependencies, especially as I'm not sure as many people would use POM or Triplanar. A few masks to choose from, less than the other options, some basic masks and then some adjusters, so you can tile the UVs and mess around with them if you want this format. This has all been explained in previous versions. It would just unlock the different sections, obviously, depending on what you select. Procedural gives you the most expensive of the options, but gives you the most flexibility. Okay, you'll see a new POM section. So we'll go through that in a second. You'll also see that you can only do primary textures. There's no secondary texture for POM. The reason I took it out is because, again, it gives the illusion of height. It didn't look good with two textures. They didn't blend properly. It looked like one was floating over the other. I couldn't make it look good, so I just took it out. It'd probably be better, to be honest, to blend the two textures by just making two of them, and honestly just putting one over the other and playing with the masks to make them blend that way. It'd look more realistic, to be honest. So that's not available, but you'll also see a big sort of change here is it does need an ORD map supplied. Now, again, this is built sort of really designed that you would probably drop Megascans assets in, so they do come with ORD maps. But the reason you need an ORD map is we want that displacement channel, because that's really what's going to drive the height. That's essentially what it is. It's basically saying, telling us the height of a given material. If we just go back up, then we'll have a quick look at how these various things are affecting the decals. So if we look at the POM section, you'll see the base depth of 0.5. This is the sort of standard depth. I wouldn't play with this too much, but this is basically the reference plane of where we start drawing our height from. So the higher the number, the further down into the material it will be, and the lower number, the higher above the material will be. The reason we don't want to play with this much is because the illusion breaks, particularly on a decal, and I'll show you. If I put this to a high number like 5, these didn't get smaller, they got further down. So what you'll see is you get this illusion, right? You're looking through a hole, the mask ends up being the hole, and you're looking down into this decal. So that is not the effect we're going for. That would look weird. You can change it a little bit, but I would generally keep it around the 0.5. You could go up 1 or 2 points, or down 1 or 2 points, but you want to leave that around there. Otherwise, like I said, it's going to look really bizarre when you scroll. The height, straightforward. This is just how high, how much you're going to use the height map to create the illusion of depth, right? I think I had it around 18 on this. I got 18 on this, so that seemed to look nice for this particular material. The minimax steps, again, if you're not familiar with Parallax Occlusion Mapping, what it's doing is essentially slicing the height map at different steps to give this illusion. Like I said, remember, it is just an illusion. There is no real geometry here. And what you'll see, the max steps are when you're looking in on the side like this. This is how many iterations we want. Now, the higher number will give a smoother look. 64 is quite high. If I go down from like 8, you can see these steps a lot clearer on a lower number. So you can see here, it actually looks quite ugly here because you can see the steps sort of breaking out to get to the height. So they've got 8 steps they're using. If you want to save on performance, you want to get the lowest number as possible. This, again, is quite an expensive operation running Parallax Occlusion Mapping. So you want the lowest number you can get away with. Maybe if you're doing a pre-render or something, you won't care. You can give it a larger number and you'll get a smoother effect. One thing I have built as a optimization in this is it does take the camera distance from the object to calculate the steps, because if we zoom all the way out here, there's really no point having 64 steps because we're so far away. So behind the scenes, it actually calculates this distance and reduces a step. So at this point, it's probably only running 1, if any, steps because we're too far away, and it's only going up to 64 as we get really close. So there's a nice optimization there, which would just help because, again, the more steps are adding a lot more computing to the material. Min steps do something very similar, but more when you're looking top down. So again, you can generally keep this number fairly low because when you're top down, you really can't see that much going on the height, but you can play around with those. General rule of thumb, keep them as low as you can get away with. Okay, now these all, or most of these, have shadows on. If I actually turn the shadows off, you'll see the shadows make a big difference to the realism, but of course they make a big difference to the performance as well. The shadows are not real. They are essentially drawn onto the material, calculated from the light direction. If you are using shadows, a couple of other options here. So the shadow hardness, of course, is really just how crisp you want it. Higher number will make it a lot more crisp. You can see I generally like a number around 1.5, gives sort of fairly nice effect, sort of blurs a bit at the edges. The shadow specular, I've added this as an option. So again, 0.3, basically the lower the number, the sort of darker, the more black the shadow will be. You can see like this, as you go up, you get this sort of softer kind of shadow, maybe representing a bit more bounce, light and impact in the shadow. I like the dark shadows, honestly, on these. I think they look really quite nice, but you can play with that. And then just like the main height map or displacement is using, shadow also has steps. So again, it's the quality, higher the number, the higher, more tax in it would be on the GPU, but and the more operations it has to run essentially, but the better the quality. So if I bring the shadow steps down to something like 4, you can see the quality drops quite considerably. 2, it breaks completely, really. Maybe 8 you could get away with. In this case, maybe 16 is probably about the lowest I'd want if I wanted a more realistic look. So something else I've also done, I'm going to show you this down here, is because we're supplying an ORD map, that means we're already going to have the ambient occlusion in the red channel. So there is a way to kind of fake the shadows, which is much cheaper than running the shadows themselves. And I've given you a side-by-side here. This decal is actually running real shadows. And again, I say real shadows, they're all faked because they're calculated and sort of drawn onto the material, but it's running shadows through the POM calculations, right? And you can see they're nice, they're dark and they're crisp. It's got slightly better contrast, but there's not a huge difference here between these two decals. This decal doesn't run any shadows, and in fact what it does is it runs, I've got this new AI power variable in the POM decal. So what this does is it runs the AO power, And to offset it, by the way, I had to up the brightness because the AOL power, it sort of is taking the ambient occlusion map. So depending on what the ambient occlusion map looks like, you might find that it will sometimes mess with the color itself. There is no, by the way, there is no way to run ambient occlusion in decals, to my knowledge. I think it's, again, the way they're rendered. So what I've done is basically I'm taking a power node and multiplying it by the base color to use the ambient occlusion that way. And in this case, because it made it darker, I just upped my brightness to 3, and essentially I get almost an identical look, and it's a much cheaper operation. So sometimes you can get away with things like that where you're not having long shadows. I mean, it wouldn't work very well with something like this where you've got these long shadows, because obviously ambient occlusion map won't do that for you. Could work well on something like this. This, by the way, is got a great ambient occlusion map because this doesn't use any shadows, but they look like they're built in really to the texture themselves, so I didn't even need to use shadows on that, and it still looks really nice. And you can see here if I quickly turn the shadows on, the difference. So cool, looks good. And I could play with the shadows, but I'd say I don't know if I really even needed them for something like that. So again, it also depends on the materials you get, the textures you get in the maps. Yeah, and I think that's really it for Parallax Occlusion Mapping. So again, you can look at the demo scene, see how everything is set up, but like I said, this does solve a lot of the issues with standard decals that come with Unreal Engine, where they don't project properly, they don't rotate properly. There is one bug, or not really a bug, I don't know what to call it, but there is one challenge. I couldn't figure out how to get it working. Maybe I'll find a solution update, but if you do rotate your textures, they do not rotate from the middle, they rotate from another point, and I cannot figure out why this is. And when I try to rotate them from the middle, they kind of break, and the normals and the height break, so I'm not really sure what happened there. But because you can rotate, and you can also still adjust your UV and your tiling, you can actually still always get the right rotation and position you need. So I've left it for now. If I can ever figure out a solution to that, I will add that in an update, but I think it's a fairly minor obstacle, to be honest, for what we're trying to do. Okay, so that's pretty much everything I wanted to show you for Decal Champ version 1.2. As always, Decal Champ is completely free for both commercial and personal projects. You can pretty much do anything you like with it other than redistribute it and claim it as your own. If you need help with anything, of course, my email is on the Gumtree product page. I try to help people where I can, but I read all the comments as well, so feel free to drop me a comment below. It's always nice to see how people are using it to help their own projects. Check out the README file that comes with this. There's a bunch of optimization things I've made behind the scenes as well to make Decal Champ more performant across the board. So I listed all that out in the README file. And yeah, I hope this tool is useful to you. I hope this video is useful to you, and it's a great asset to your development. So anyway, thank you so much, and bye for now.